Hi, Kavu.
Afternoon, Jianpeng. So we have full quorum here because Chime is on holiday. Um, let's start from me. Last week I was working on fixing some regressions introduced by some latest changes on Messenger to get the mock client test and the Mentor CC driver back to normal, but I'm still running into some version failures when the socket connection destructs itself. It
Mm,
it it, it crashes in the function I'm posting in the chat in
okay.
here. I guess it's impacted, and because we are forwarding the failed permits to the waiting future without checking if it's actually possess exception, right? If I
Yes.
recall correctly, there's some to-do comment in our messenger. We might need to fix it sooner or later.
Yeah. I'm looking at the fixes of this one and trying to unlink uh, the forward operations and hide the exceptions inside the connection. So I think it is working, but I still need some more. Yeah, this commit.
Okay, thank you. But it's not blocked, I think, because it only happens when the application exits. And
Yeah.
I'm currently
I'm
and
doing this.
Please go on.
Yeah, I'm doing this because the concurrent sharded messenger has some bugs and some exceptions are hidden because of their poor designed interfaces. So I need to first address this issue and then try to debug the sharded messenger.
By what do you mean by this issue? Is this related to the interface we have, right?
Yep. Yeah, because some errors are throwing from read or write operations, but the connection doesn't handle it well, and it will
Okay.
become segment fault for some cases.
Even the failure exception are expected.
Yeah, so because it just breaks the connection and breaks the code, and through the exception the messengers is shut down with dangling futures, so only segment fault will be printed, but not the root
Okay.
cause of the issue.
Okay. I assume that we do have the painting gate regarding such kind of an error, but
Yeah,
yeah,
but
we need
the
we need to.
gate doesn't protect the send interfaces.
Okay. Okay. Thank you.
Yeah.
And I think my next step is to to connect the to mentor CC with the object store so it can read and write the super block and to get it boot up to connect to the cluster. And currently, I'm not planning to integrate TrimMate's work into the mentor CC integration, and because we can consider the memory store a synchronized device, and later on I will I will to I will integrate Trainbase work and consider it as an async device. Once the boot up work is done, and that's me. And I will take like 4 days days off before next year. And Jianpeng, is there anything with us?
Last week I completed the sync message performance test with the FR message engine. And now I based the Seastar message code to modify to make it can accept what the OP for read and write.
Okay. So it's a standalone test, which what is the driver looks like? Is this a ordinary Redis client or some messenger
No. Use the PR you mentioned as the same client to test a sync message and
okay.
C-star message to compare the performance.
So basically, interoperability test where the alien messenger talks to a Seastar messenger.
Yeah.
Okay. But I wonder what the pressure would be like, because there's only a single message, a one-to-one mapping. A single client talks to a single server. I'm not sure it's hammer the messenger enough to get the right number.
For the our test is I improve the client to make use of the NRC to make use of the NRC. No.
Do you have a working progress PR or a branch so I can take?
No.
Take a look at?
I'm only in my log test. After complete this, I may send the result.
Okay. So how does the number look like?
For my 10 gig NIC, the sync message only for client will meet the bottleneck of the NIC. For client will meet the bottleneck. 270 key IOPS 4 key random write and 4 kilo random read and write.
Okay, that's how async message performs, right?
Yeah.
But we still don't have the preference number of the system messenger.
Yeah, because now the Seastar message can't work for when client is on the other machine and the server is on the machine. So I modify the code to make it work.
Okay, thank you. So I'm just curious regarding to why async why the Christmas messenger doesn't work, and if the client and server are located on two separate machines. Is this a problem how we are using Seastar, or it's just an issue in the driver, or put in other words, the test?
Pardon, what mean I can't follow you?
I think Jianpeng is using that FIO messenger engine to integrate it with Chromosome messenger directly, so that two Chromosome messenger can be tested from client server side. So the cooperability from async messenger to Seastar messenger is already tested, right? But if we need to test from Chromosome messenger to Chromosome messenger, or from Chromosome messenger to async messenger, we need the FIO engine works with the Chromosome messenger interfaces.
Okay, I see. And by the way, I'm currently reviewing the LRU error cache changes by Jianpeng and by Redoc.
Yeah, I see your comments.
And Redoc, how's it going?
Hello, I'm working on to put together the shared messenger with yours prototype of OSD driver. I have it buildable. The problem I'm focused on right now is trying to bring the monitor client to the shared messenger. Because interfaces has changed, especially the connect method. Well, we have some complications there, like the connection cross reference. I posted some comments on the.
Yes, I saw it.
And well, I'm not sure which policy should I take. Is it acceptable to go with the with wrapping each send method via invoke on?
Invoke on.
Let me post link.
Or submit to.
Enforce.
Well, just redirection, scheduling. The send part on the core, the connection ref belongs to.
Actually, in my opinion, we don't need to submit to a schedule on or invoke on when the connection is moved to the connection or to the core where we want it reside.
Well, it's about making new connections actually, not about accepting. Accepting is different. It's different topic.
Yeah.
Actually, we might have issues in both locations. Here is about the connection cross reference in the modified connect method.
Mm-hmm.
I'm afraid we can have data. We can actually use the same data in read-write manner on many Seastar engines.
What do you mean by the pointer still can be dereferenced on local one, exposing connection reference and connection itself for asynchronous modifications?
Let's say that let's say that the connection belongs to core A.
Yeah.
Core B makes calls the connection and gets the connection cross-ref instance.
Yes,
Then,
from A, right?
Exactly. Then from the core B, we want to send data to the client. So
Yes.
I guess we would need to dereference the outer third low weight pointer, get the foreign sharded pointer to the connection ref, I mean. But it means that it can be actually, I'm afraid it can be used from many cores at the same time.
So why the reference is needed here? I don't quite understand.
You are getting connection. 1 second. Writing this out. Connection crossref instance.
Yes.
MSGR connect. Let's forget about the future a bit. Let's say we got let's say the connection is ready for use, and we want to use it. But to use, we need to do something like that.
Yes.
And I am afraid that if we do that from the core B, we can have also another users, or maybe in core A or any other sister core that wanted to talk with the same IP.
I think it's if you check this send interface, it will submit to the shard where the connection belongs to. Let me check. And, okay. I think you are referring to this logic, right?
Yep, and but that's one possibility. Another one is to write something like copying the reference, something like copy on the ref. With such idiom, you can get, well, foreign pointer is not copy movable. You would need it's not copyable. You will need to move it.
But the foreign pointer can be wrapped by a local shared pointer, so it can be copied. It only the foreign pointer will be the only one instance in the foreign core, but the local shared pointer of that foreign pointer can be copied around. So that's why this is designed, the X reference.
Okay.
Yeah, X.
Okay. Sounds good.
So that the XREF is this thing. So this is the actual X reference. It is a LW shared PTR wrapped the foreign PTR. So this one can be copied.
Sure. Now I understand. basically we have, also we are returning non-const connection reference, still guarantee there is no problem because of using the RPC. Sure.
Mhm.
Okay.
Yeah, I just saw similar implementation in ScyllaDB, so I just reuse the design here.
Okay. Cool. Also, I was taking a look let me provide a link on the debug shared pointer counter type that can be used to verify some invariants of shared pointers in Seastar, especially in the scope of the accept of moving the connected socket during accept phase of connection.
Yes, I was also discussing this with Yingxin yesterday afternoon. Oh,
And can we actually do anything with the issue just except basically extending Seastar?
I think our decision is to just leave the socket to the original core and use the input string and output string from another core. But since there's only one connection, we'll use the input and output string. So
yep, it's technically it's safe across at least the POSIX stack implementation.
yeah.
The only issue is just not returning the memory to proper shard.
Yes. Maybe the buffer will be created from another shard.
I was thinking about the load balancer Seastar the POSIX stack has internally.
Mm-hmm.
It's not well. I haven't found any point that would allow us to define our own placing policy. It's not extendable, but if we have such feature, we should be able to actually guarantee no issues with the debug shared pointer. Plus, doesn't change the policy we have right now.
But there is a issue here because the load balancer is only working when the socket is accepted, right? But our requirements needs to move connection after the first banner change. So the connection will know the peer address nonce and the nonce and port. That means the full peer address.
yes, because the replacement is requirement by messenger protocol.
Yeah, the full peer address is only available after the first banner exchange.
Okay.
So,
now I see.
Yeah, but if we can leverage it from the load balancer, we can at least balance the socket with IP only.
Sure. That's the policy we have right. Actually, we have in the RFC PR, right?
What is RFC PR? Yeah.
Let me link. request for comment.
Okay.
The one you sent in string.
Current, do you mean this PR, the Crimson Net enable connections on all cores? You mean this one?
Yes, exactly.
Yeah, this is, I think this has some bugs here because it is moving the connected socket, but I think the Seastar doesn't allow us to do that, and it can introduce some buggy behaviors. And actually, I just saw some bugs with segment fault with this implementation, but it just happened randomly. So it proves that it is caused by some race conditions, maybe from different cores, but I'm not clear yet. Maybe related to our moving the socket, the solution to our current implementation to move this connected socket between cores. Maybe it is related to that.
How do you trigger the segment fault by using the what test you can
just run the unit test multiple times. You will see it can pass, and sometimes it will fail. It just doesn't success randomly. It can success, but sometimes not.
So is the test messenger underscore messenger, right?
Test underscore messenger underscore new.
Okay.
Yeah,
okay, I see.
it is
The one you typed in the PR.
Yeah, it's shipped with this PR. Yeah, it is triggering multiple connections. It creates two clients and two clients and two servers, and establish four connections each other, and start to send ping pong and keep alive to each other.
Okay. I will play around with it in my holiday.
Thank you.
By the way, I can see in the PR, I can see we are sharding on the IP address.
Yes.
So isn't it enforcing? Isn't imposing the need to move the computations to another engine when we will be passing the flow to OSD shard?
What do you mean by passing the flow to OSD shard?
OSD will be implementation of the dispatcher interface, if I understand correctly.
Yeah.
So when a client is getting accepted by one of the shards of the sharded message. All the low-level RADOS processing happens in the core the connection belongs to, and we want to start some higher level operations like, let's say, read. Of course, it will be in the OSD class.
Yes.
But we know that data that we want to read on won't depend on the IP address of the source IP address of the peer. It will need to be available to all clients independently of their IPs. So it seems it might be that we are getting data available on let's say handled by core B from a connection that belongs to a core A.
Mm-hmm.
Doesn't we need to go through submit to or something like that? I mean, change our change the new core executing a particular flow.
Yes, if it is going to the PG, the OSD will be responsible to
Sure.
dispatch the message between cores.
I see.
And
So
if
inside sorry, please continue.
Yeah, so there are two different scenarios. The first is when the message is received by OSD, and OSD will responsible to dispatch the message to the corresponding PG. It is maybe cross-called. And another scenario is if PG wants to send some message, maybe some reply to other peers, the PG itself will hold the connection instance and call its send interface, and the cross call will be handled inside the connection itself.
Well, I'm asking this. The sharding concept looks pretty complicated to me, and
Yeah.
I'm just considering the most dumb scenario possible. I guess a scenario with without any sharding, basically shard nothing, with Messenger and OSD and the final object store implementation sitting just on one single physical core. Of course, this would mean a lot of OSDs, even on the same device. Hey, Reed, Kifo, thanks for pointing out the article about user space IO scheduler. Well, this looks pretty interesting. I'm just trying to identify the trade-offs we have with the sharded design. Definitely, we are saving a lot of connection-related resources. But is this meaningful saving?
So do you mean that we just create the same number of OSD with the number of CPUs?
Yes.
If
it will be after limit.
Single process and a single threaded CPUs. That's what Redux is suggesting.
Okay, so that means that nothing can be shared between.
Exactly.
Yeah.
Yes.
That's very. I don't know.
It's a pure share nothing design, and the downside is it's share nothing, and outside is also share nothing.
Well, I can identify definitely two problems with absolutely shared nothing. First is of course a lot more connection and
Yes.
resources consumed by them. Still, I'm trying to judge how costly, how truly costly is having one extra connection. Another thing is of course the case of the user space IO scheduler of system. In shared nothing, I guess we won't be able to use it. That's the two downsides I see it now. But the opposite is just making the architecture very simple and without any cross-core jumps, without changing any execution flow across cores.
Is it reasonable to have OSD number to match the CPU number, but not the device?
Well, the number of physical core will be the upper limit. And of course, you can for spinner. Basically, you will have so many OSDs as you have spinners inside your host. But for faster devices like NVMEs, well, even now it's not unusual practice to see multiple OSDs occupying the same device. They are just divided on the partition manner. They are just partitioned. And I saw Intel is there was some Intel testing, and I saw it's quite usual to have even 4 OSDs per single NVMe.
Mm-hmm.
Yes, I recall that.
For one.
But I wonder if we can postpone the decision for later, because
I see.
If our design is flexible enough.
That's the pain.
Yeah, because if we can hide the shared infrastructure underneath the encapsulate them underneath a layer, probably we can postpone the decision for later.
True. It might be easier to squeeze the sharding that implement it later.
Yeah. So Redak, if we are going to this way, we can. So why do we need the Seastar framework? We can just reuse our existing implementation and just create them and ping them to one core. And
no, it won't work because well, it technically it will work, but will not be performant enough. Because you will got a lot of context switches. Because our messenger, because actually we have pipelined architecture in a current OSD. There is a messenger thread, there is TP-OSD thread, and for writes there is even the Bluestar sync, Bluestar finishers, and a lot of threads. If you would all pin them down to single core, you will see a lot of context switches, while still maintaining the painful synchronization.
Mm-hmm.
In shared pointers, in boost intrusive pointers, in all that stuff.
Yeah, and if we have many OSDs in one host. So for example, a host may have 20 CPU and we create 20 OSDs. So there will be much more OSD in the cluster than before. So, and each OSD in the same host will need to connect to each other.
True.
So
It grows the number of connections. Sorry, please continue.
I don't think it's worse than what we have in existing OSD. In existing model, each OSD manages a single, let's say, an object device or partition assigned to that OSD. If we have for example, like 20 devices or partitions for each OSD, we will have 20 of them in a single host.
okay.
In existing implementation, there will be 20 OSDs. But if we use the one-to-one mapping as suggested by Redoc, we also will have 20 of them. But there's a lot of less competitions in a single process, or put it another way, in a single thread, because they will share the single CPU, and they won't be competing with themselves, because it's pretty much a user-based scheduler in each of them.
Well,
that's why we are going to leverage Seastar for this design. We can also benefit from Seastar.
That's entirely correct for the spinners case. For NVMEs, when we can, especially for random reads, when we can leverage the multiple TP-OSD TP threads, I would expect we would need to have a bit more OSDs, but the upper limit is 8 times more. But on average, I would expect maybe 2 or 4 times more on NVMEs only, of course. Because by the default number of shards inside current OSDs is 8.
Mm-hmm.
Sorry, I don't follow. Where the number come from? 8.
Currently, some portions of the pipeline, the TP stage of current OSD pipeline is sharded. It has by default 8 shards serviced by, and each shard is by default serviced by 2 different flashes. So
okay.
if your operation is well parallelizable, OSD can consume a lot of CPU cores. By putting the limit 1 core per OSD only, we would need just more OSDs to saturate a fast device. But I wouldn't expect the number will be bigger than maybe 8 or something like that. That's the upper limit, I guess.
Agree. Probably it depends on the hardware IO depth of
sure,
of the
entirely
device.
correct. And for sequential, it also depends on workload. For writes, no difference, I guess, because we are bottle. It's basically 1 thread only workload. It's not parallelizable. The same for even reads, but sequential ones. We are still held down by the PG lock. The case that is the best candidate that is a subject to the huge portions of parallelism inside OSD is just 4K random read. So pointing out that we would have more connections, well, connections between OSDs actually in a cluster is valid, I think. For very fast devices, we would need to deploy more OSDs per device.
Yeah.
Okay.
To take full advantage of the throughput of a static device.
Exactly, to saturate it. But this is about the number of connections between OSDs. I guess the number of connections between client and OSD would grow linearly.
Mm-hmm.
I don't know how really costly is having additional connection. If it's just memory cost, small memory cost, maybe it's still acceptable. I don't know. I'm just thinking cloud. I'm just considering possible scenarios.
I think it's more than just more connections. There's more bookkeeping work, for example, to get connected with the manager and the monitor, and to get updated by the OSD map, for example.
Definitely for OSD map. Also, maybe more bookkeeping in the kernel stack, in the kernel network stack implementation. But I'm just speculating here. Maybe the data structures they offer are the lookup is constant in costs. I don't know.
Sorry, I don't follow. Lookup of what?
For instance, a translation from file descriptor to internal kernel data.
You're still talking about the connections, right?
Yes, about the cost of about the real cost of increased number of connections.
I don't think it's a big deal to have more connections. I'm just concerned about the OSD map overhead, for example.
How costly is an entry inside OSD map?
Not sure. I'm not sure about the number. I just recall that there are quite a few performance improvement regarding to have a less memory footprint.
Okay, I see.
Of OSD map. For example, we
will increase in size, of course.
Yeah, three level of OSD map cache, and to only memorize the delta between cache map and OSD map, etc. I don't think we do it for no reason. But what I can think of is that the counteract of this the problem is to make sure we have good understanding and good design of what kind of part of our work can be used can be both of these approach, the single process approach and the multi-process approach. For example, the core shot messenger is definitely serve for the multiple process of multiple threaded Crimson OSD, while the single process before we migrate to the multiple cross-core messenger, the design works for the single threaded messenger, and we need to also to have a clean line between them to make sure we understand which part of them can work for both of them and have a better design. If we we feel that it's very complicated and it's not worthwhile, we can switch over to the single-threaded design.
I think if
That sounds good.
we implemented the sharded messenger properly, it can just fit for the need of the single-threaded design messenger.
Sounds interesting.
Yeah, because we only have one shard now, and the Crimson messenger just accepts that fact.
Sure.
Yes, with some overhead, if we want to go with the single-threaded Crimson OSD.
But this would allow to very easily test all parts that are put there in the project just with the sharded with single messenger implementation. And if we discover that that we have additional costs related to just being able to handle multiple shards, we can quite easily squeeze this overhead, I guess.
Mm-hmm. Yes.
I think the current, from the practical perspective, the problem is that the design of multiple threaded or multiple core design of Crimson OSD is complicated. That's why I think, Riddle, that's why you are looking into some simpler design,
Yes,
right?
that's also true. That's the reason that encouraged me to try to see different views from different angles.
But I'm wondering, what's the next complicated design aside from a cross-core messenger? Is this the last one obstacle or last problem we need to face in the?
I'm afraid we will see similar issues in the sharded OSD.
But okay, PG is fine, but we need to share a lot of status. For example, in the future OSD service, right? Another problem.
OSD survey.
Service.
So service.
Which
okay.
Offer,
okay.
Yeah, which
sure.
offers share. What this is a catch-all service for the PGs, non-sharded part.
Mm-hmm.
Yeah, sharding is just complicated.
But the upside of it is we have full control over the
we can use, for instance, the user space I/O.
Yes, sharded OSD service. Unlike the connection, for example, we cannot manage the life cycle of a FD or pullable FD. That's why we have trouble to hack it or extend it. But when it comes to sharded OSD service, the problem disappears. It's a little bit easier for us to hack on it.
Yeah, we will have better control of the CPUs and the network and the devices with the sharded design, and we will have limitations if we stick all of things with CPU, right?
Yep, I don't follow you. What the limitation is?
So if we just limit everything with number of CPUs, so there must be some limitations there. But I don't know. I don't know the list, but I feel so.
Could you name some of them? I'm lost actually.
Redact, do you have some thought about?
I guess so. let's say we have less cores than spinners inside host. That might be issue.
Yeah.
That's cool.
But still, can a Seastar process share? No, it cannot. It does at least while using DPTK or SPDK. I guess they will be consuming each core regardless. They will be consuming a core they are assigned to regardless of the workload, just by polling, even if there is no work to do. Sorry, thinking loudly.
So you mean we could be wasting some cores if the number of the cores is plus the number of devices.
I guess we wouldn't be able to have more devices than cores in host.
Oh, that's possible. Yes. But I'm afraid it's not really practical in present deployment because
might be, yep, that might be valid.
Yeah, it's the high dense in a high dense 2U box there could be like 20 disks, but in a high end CPU and a high end CPU there could be more than 40 threads and more than 80 of the hyper threads. So it's, I don't think it's a problem. But it could be limit, but it's not a problem in practical.
But I wouldn't. I'm not sure it's good idea to include the number of logical cores, only physical. I don't know about anything about. I don't know how the event loop behaving with the POSIX stack. But if I recall correctly, the DPDK is designed in a way that encourages polling. So even if you don't have any workload, you are still wasting a lot of resources just to poll your NIC, your network device.
Another issue I can think of is if we just put everything in one core, we cannot divide them. So for example, we can put the critical I/O paths or critical processing into one core and put other periodical or non-critical tasks in different cores.
Well, we can always prioritize them, right?
True, we can have also execution stages, and if something is really called something is very unfrequented and coming from current world, we can use the alien.
Yeah,
I guess.
Oh, okay.
But this is also advantage in some cases. If you don't need to switch your cores, if you don't need to change the core executing a given flow, you can leverage some localities.
I think the same applies to the multi-threaded solution.
Sorry, could you
During the
repeat,
case.
please? There are some network jumps.
Yeah, I think your assessment also apply to the multiple core or multiple threaded design. It all depends on how you batch the task or how to
Yes.
schedule the task.
How you shard? How effectively do
Exactly.
you are sharding?
Right. But do we have a consensus now,
Well,
or we are just
I'm
put
not
all the
sure.
problems on and advantage on the table?
I guess the second option.
Yeah, it's a second option.
You just
You
don't
mean
know.
the single-threaded OSD, the second option, right?
Second option is that, well, by second option I mean that we are just considering
Okay.
without
Okay. Cool.
without concept at the moment.
Okay. Probably I think probably we can also send a mail to the safe devil to get more inputs.
Yep.
Yeah, because I'd say it's a very very big decision, or something we need to think it seriously.
Mhm.
Yep.
And if we
It's
cannot have a very flexible design, we need to make decisions earlier. But I believe that the to be optimistic, what we have now is can be reused by both of these this design.
true. By the way, do we have uh, do we have an object store interface with compatibility with Seastar? I mean, I'm asking it is part of the read the critical read IO path. Chumney is
Yeah,
asking has sent me an email about dividing the work inside the IO paths, and I'm thinking about possible stages.
I'm thinking about it, but I, the answer I had is that I'm trying to avoid it because I'm currently trying to focus on the bootstrap stage of OSD. But regarding to the IO path, I think I don't think we have finalized the async interface of the OSD storage, and I don't think we haven't it nailed down yet.
Yep, because for read paths, for the read path, we would need definitely, of course, the read method of object store, but also some extra things related to handling, for instance, object contexts.
Yes, I think that's why Tremaine introduced a store context.
Okay, that sounds. That's a thing I'm not familiar with. Is there a PR for it, or is just a concept written somewhere
No,
else?
it had a PR for it. She had a PR for it. Let me send you a mail or once I find it. I think it
Well,
even have a
Kifu, I will. If she has sent the PR, I will find it. No problem. Not problem. Don't need to bother you with that.
um. Actually, it's easy because we have all the Crimson PR labeled with Crimson.
Yeah, but
Easy to
that's
find.
the first place where I started looking for.
But I didn't take a closer look at her PR. We 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 definitely need to get a better idea how the OSD object store interface for going to look like. But that's a start point.
Okay.
But if if you are if you focused on the, for example, read path, I think it's not a dependency of
Yes.
your work.
That's the reason why I'm asking, because we can have some possibilities to parallelize the work. If we agreed on interfaces, we can.
I see. Cool. But Rido, I suggest that you take a closer look at her PR and
Yep.
to find something we can work on to get closer to what we expect.
Sure. Thanks for the link. I missed it out. Sorry.
No problem. Before she back from her holiday. I think we are overdue.
Sure. She will be available. She will be available since New Year, or she's tomorrow in the office?
I don't think she'll be in office before the New Year.
I see. Okay.
I think we are overdue, and Happy New Year, guys, and see you next year.
Thanks.
Anything
See you next year.
we need to discuss before? See you next year. Gentlemen, Yingxing, how about you guys?
Happy New Year.
Is there
I don't have.
anything we need to discuss? Okay.
No.
Okay. Stay around. See you next year.
See you
next year.
Have a good day, guys.
Bye.
Good afternoon.